Good morning to all of you. Welcome you guys. Welcome you all. Very good morning to everybody. Yeah, first of all, you do check this audio video quality. Is the audio video is clear to everybody? Tell me, first of all. I think we are live. So here, audio video is clear to everybody. Tell me, first of all. ठीक है. So, and check this audio video quality here. Is the audio video is clear to everybody? चलो आज का सेशन हम शुरू करेगा. Right. And so before that, we have a great announcement from Unacademy, that is GATE 2024. So Unacademy students has get the 7 AIR 1 ranks. In the different branches, you can have a look at now here: electrical, CSIT, ECE, CH, IN, PI, NM. All these branches, the toppers are from Unacademy only. Now it's time for you can start your serious preparation with the Unacademy to achieve your dream goals. Right, so we are providing the great offers. You can see now here, flat 60% of discount आपको मिलने वाला. The offer is valid up to 8th of Feb. That is today is the last day to avail these opportunities. Right. Now we started the new batches. We have started EMT and as well as the digital logic circuits for both EC and electrical Kelly and 2027 batch as well as 2026 batch में. ठीक है. And so these are the plus features you can see now here: raise the hand option, class doubts, polls, daily practice problems, DPPs will be provided, educator communities, live, learn live from the comfort of your home, study material, unlimited access, and top educators of India. Right. So this thing. So today we are going to start the most expected questions of the networks. All of you do join the session fastly, everybody. All the students do join the session fastly. We are going to start this live class. We are going to see and we are going to discuss about the most expected questions of the networks. Okay? Right. So take this question now here. A particular resistor R dissipates a power of 4 watts when V alone is active. The same resistor dissipates a power of 9 watts when I alone is active. The power dissipated by R when both the sources are active is. Right. So here we can find the two sources are there. You can see now one is a voltage source, the other one is a current source. And what they're saying here, when only this voltage source is active, the power is given as what you tell me now 4 watts. That is they given this as P1. It should be given as what tell me now here 4 watts when only I is active. And the power that is P2 which is given as what tell me, that is a 9 watts when the current is active. When both are active simultaneously, now they are asking what will be the power. So that should be given as what we can say now here, this is power. It should be equal to, according to SPT, that is given as square root of P1 plus or minus square root of P2 the whole square according to SPT. Right, so that means it should be given as what I can say, tell me now here, that is square root of P1 which is equal to 4 plus or minus square root of 9 whole square. And you can see this thing here, what will be the answer? So that should be given as P. It should be equal to 2 plus or minus 3 का whole square. अगर प्लस पॉजिटिव ले लिया तो 5 स्क्वायर इट इज ए 25 वाट्स मिलेगा. अगर नेगेटिव ले लिया तो विल गेट इट एज 1 वाट मिलेगा. सो कौन सा ऑप्शन यू टेल मी नाउ हुई है? ऑप्शन डी एंड ए दोनों में. ठीक है. नेक्स्ट में when see this thing here, when Vs is equal to 120 watts, it is found that I1 is given as 3, V2 given as a 50, power delivered to RS given as 60 watts. If Vs is reduces to 105, they are asking the new values. They are asking, right? Here you tell me now here initially when Vs is equal to 120, Vs is 120 in this scenario, they given the data. What they given, you see this thing here. So this is I1 value which is given as what element here 3 amps, and then V2 value given as what 50, and the power. So if I call this as a P3 which is given as what element of 60 watts given. Now they changed the values. Now they changed these values to what you tell me. Now the new values they given as what you tell me now Vs value. अभी Vs value ना क्या दिया इस उन्होंने. So the new supply, let us the new values which is given as what you tell me now 105 volts दिया. Now you tell me now what a change you can find. You tell me now here. So here the coefficient, if we call it as what tell me now new by old one. New by old. So how much this value you tell me? That is K value. New value is how much? 105, and the old value is how much? 120. So from this you can find the K value. So it will come to be a what element of 5 2s 1, and this is 5 2s 5 4s. Right. So here we can again cancel it now here. 3 7 3 8. So the K value is how much you tell me now? 7 by 8. That means if the excitation is multiplied by some constant K according to the homogeneity property, if the excitation multiplied by some constant K, the response in each element is also multiplied by the same constant. So that's why what I can say, the new values of this is I1, the new value, it should be given as what you tell me now here, that is K, that is K into what we can say this is I1. So what could be the new value? Tell me now I1 dash, it should be given as what tell me now here, 7 by 8 into I1 which is equal to how much? 3. So it will come to be a what tell me now here 21 by 8 amps. Next, what about this V2 dash? You tell me the new value, that is 7 by 8 into what tell me now here new, this is 50. Right. So if I cancel it now here, so this value 2 4s and this is 25. So how much will come here? This value it is a, so here 25, so 175 we can say now here, 25 into 7, 175 by 4 aega. Right. Next, what else you see? The power. So you see this thing here, power, whatever the new power you tell me now here, voltage multiplied by some constant K, current multiplied by some constant K. As a result, power is multiplied by what we can say now K square of the initial power. So that means what I can say now P2 dash, K value is how much now here? 7 by 8 whole square by initial power, which is equal to how much you tell me now? 60. So how much the new value of power you tell me? 114.6 84 चेक करके बोलिए ना भैया ये values do calculate check the values done next one see the next problem when R is 10 ohms VR is given as 20 when R is 20 VR is given as 30 find VR when R is 80 now see the problem they given some the DC network R value is given when R is 10 VR is given 20 when R is 20 VR is given 30 so today we are going to discuss the theorems topics thereafter tomorrow we'll see the transients tomorrow we'll see the transients right now you can see now what we can do here the DC network according to Thevenin's theorem the complete network we can replace as a VTH and RTH हम replace करेगा so the complete network we can replace it as what element of simple Thevenin equivalent से replace करेगा this is VTH and this is RTH and here whatever the load is there that load will connected here that load will be connected here that load of course they given as R given so take it as R only the load is given as R yeah you can tell me now here now so this voltage which will be a voltage across this resistor this is VR yes now you can tell me now here this VR means what you tell me now we can apply VDR so that is voltage addition when you apply that is VR which is equal to what tell me now here R by R plus RTH into what tell me now VTH right so now they given the conditions you see this thing here when R is equal to 10 VR is 20 we can substitute now here VR is 20 when R equal to 10 by what I can say now 10 plus RTH into what tell me now VTH so if we cross multiply so you can see this thing here what I will get now here 10 into VTH which will be equal to what you tell me now here 200 plus 20 RTH right this is one equation now second condition given now when R is 20 VR is 30 we can apply this condition also now when you apply this condition now you tell me now here these values so they given this as VR value is what element 30 which is equal to R is what element now here 20 by 20 plus RTH into VTH so if we cross multiply now here what I'll get now 20 VTH and which will be equal to 6 that is 600 plus what will be now here 30 RTH and this is a second equation now simplify this one so by two equation two unknowns we can solve it now here so that should be given as 20 so it will be a 2 into what I can say now here this is 200 plus what element of 20 RTH that is equal to what element of here 600 plus 30 RTH. So it should be given as what to tell me now, 400 plus 40 RTH. It should be equal to what I can say now here, 600 plus 30 RTH. Now simplify this thing here, 10 RTH, which could be given as what element of here, 200. So from this RTH value will come to be how much, 20, and this is RTH value. Now this is RTH value. So from this we need to get what element of VTH. So substitute the value in the equation 1 or equation 2, will get the value of VTH will come. So here how much the VTH value, that is 10 into VTH equation 1, which will be equal to what to tell me now here, 200 plus 20 into 20, that is 400. So how much the VTH value you tell me now, that is 66. Yes, this is the VTH value now here. अभी हमको क्या चाहिए, you tell me now here. When R is equal to 80, they ask him to find the VR. So we can suppose the same thing here. Now VR, we need to get VR now. VR equal to R value how much? R is 80 by, so this is R value 80 plus RTH value 20 into VTH value 60. So this is how much will come here? That is 80 into 60 by 100. So here, so we are, so here that is 48. So कौन सा option you see? Option C. Got it? Next one. In the circuit shown, which one of the following theorem can be conveniently used to calculate the power consumed by the 10 ohm resistance? So to find the power across 10 ohm resistance, what theorem we can apply, you tell me now here. So here what type of supplies you can see now here, we have a two AC supplies we have taken. AC supply, this is also AC supply. And here the frequency omega value given as 100, here the frequency omega value given as 200. Frequencies are different. Whenever the frequencies are different, so what theorem we need to apply, you tell me? We need to apply only the superposition theorem हमने use करना पड़ेगा. If the frequencies are different, we need to go for superposition theorem. So consider one source at a time, we need to analyze it. So SPT हमने use करना पड़ेगा if the frequencies are different. Next one. Right. Find the Thevenin's equivalent resistance of the circuit to the left of the terminals marked A, B. If the frequencies are same, so you can do it as any theorem chalega. If the frequencies are same, you can use this one as a Thevenin's theorem, we can apply. If the frequencies are different, so what we should do here basically, so these inductors, capacitors, we need to convert into resistance form. If you have two frequencies are there, what frequency to be taken? So here we should, when you convert now here, the inductive reactance is what, tell me now here, J omega L. Capacitive reactance, which we can say it as what, tell me now? So 1 by J omega C. Here two frequencies are there. Which frequency has to be used? So that's the reason we need to consider one source at a time we have to consider. If the frequencies are same, yeah, you can do it as what, the best possible way to do this type of problem is a Millman's theorem. Millman's theorem. We have seen the Millman's theorem expression हमने देखा ना. So if the sources are number of voltage sources connected in parallel, that expression use करके we need to find out. Right. Find the Thevenin equivalent resistance of the circuit to the left of the terminals. Right. So we need to find the Thevenin's equivalent. Left or right they has to mention. They should mention right. They has to mention, no? Not left. AB is the right side. So here this thing. Thevenin's equivalent resistance we should find, right? RTH value we need to find. Right. Tell me now here RTH के लिए क्या करो इधर? We will apply the VTIT method. We apply a VTIT method. We apply the VTIT method. This is IT. So this is minus, this is plus. Here this is how much this value 10 into VI. And this value is what element of 2. And the value given as, this value given as what to tell me now here, VI. And this is what we can say now here, 5 volts. Yeah, now you can tell me now here. So here, this is the open circuit. So then there is no flow of current. Right. So here we need to find what, tell me now here. So directly resistance only. So I will deactivate this voltage source simply. I will deactivate this voltage source. If I deactivate this voltage, so there is no VTH. If I need VTH, keep it. If I don't want VTH, deactivate the independent voltage sources. Or you can keep this one. We'll get the VTH भी आपको मिलेगा इसमें एक साथ मिलेगा. Now you tell me now at this location, this is VT and this current is what you tell me now here, IT. Right. So if we write the KVL in this loop, so you can tell me now here what we'll get now here. This is VT, which is equal to here is path mein this is open circuit, so current is 0. Pura current IT will go in this path. So this will be given as what, tell me now here, 2 into IT minus 10 into VI. Right. Now you can see now here, to get this VI, we apply the KVL in this loop. If we write the KVL in this loop now here, tell me what we'll get now here. This is minus 5 plus VI and this is plus 2IT minus 10 VI equal to 0. Now simplify this thing here. It will be equal to here minus 5 plus 2IT. This equal to what element of 9 into VI. So that is VI value is how much you tell me now here? 1 by 9 into that is minus 5 plus 2IT. So from this we can come the VT value as what element now here? 2 into IT. Okay. Minus 10 into VI, that is by 9 into what element of minus 5 plus 2IT. Now you can say this is VT equal to what element of here? 2IT minus minus plus 50 by 9 minus 20 by 9 into IT. अभी हमको क्या चाहिए? You tell me now here. That is VT. It should be equal to what I'll get. You tell me now here. IT we have taken common. IT we have taken common. This is what will be now 2 minus 20 by 9. Right. Plus 50 by 9. So how much will come here? This is IT into, this is 80, that is minus 2 by 9. Plus 50 by 9. ये आएगा. So from this, what is this RTH value? Tell me. So this is RTH value. It should be equal to minus 2 by 9 ohms. And the VTH value how much? That is 50 by 9 volts. So this is minus 2 by 9. So कौन सा option you tell me? Option तो नहीं ना? Yes, so this is none. Yes, RTH value can be negative. RTH value negative, that negative value of RTH, that is because of presence of dependent sources. If the network contains dependent sources, the RTH value may be negative also. Okay. RTH value negative bhi ho sakta. That is, the negative value of RTH will indicate that the nature of the network is active. Network is active in nature. And take the next one. Which one of the following combination of an open circuit voltage and Thevenin equivalent resistance represent Thevenin equivalent? That means they ask you to find what. Tell me now here. VTH and RTH value we need to find out. VTH and RTH value we have to find. Below, let's find out this thing. So here I can do the VT80 method now. So remembered all of you the VT80 method. So this is VT and this is IT. Now you see this thing, this current is I1, this current is 99. So that this current is what we can say now here 100 I1, but this is IT. So from first observation, what I can say now here 100 I1, which is equal to minus IT opposite direction now. Right. So thereafter we are writing this now KVL in this outer loop. KVL in this outer loop. Tell me now what I will get. That is VT equal to what we can say here. So this is minus 1K into I1 plus what? Tell me now 1. So then which will come to be a VT, which is equal to what? Tell me now. I1 is equal to what? Tell me now here. This is minus 1, that means 10 cube. I1 equal to what? Tell me now here. This is minus IT by 100 plus 1. So that is VT equal to what we can say now here. Minus or minus plus, that is 10 IT plus 1 will come now. So from this, what I can say now here, what is a VTH value from this equation? The coefficient is VTH, that is how much now? 1 volt, and the RTH value is how much? That is 10 ohms. So कौन सा option? Tell me. Option A. Right. Next one. So in the circuit shown, the power consumed in the resistor R is measured when one source is acting at a time. These values are 18, 15, 98. When all the sources are acting simultaneously, the possible maximum and minimum values of power in the resistor is. So previously we have seen for the two sources, now it is a three sources. And what will be the power, you tell me now here, that is given as, we can say plus or minus root P1, that is plus or minus root P2, plus or minus root P3 whole square. Now you can tell me now here, these are the sources powers they given now, that is plus or minus, that is root P1, which is given as what, tell me now, 18, plus or minus what will be root P2 given as 50, and plus or minus root P3 value given as what will be now 98 का whole square. Now simplify it now here. Now हमको maximum के लिए, so all the values must be positive होना पड़ेगा. Yes, maximum के लिए what I can say now here, that is root 18 plus root 50 plus root 98. This is the maximum value now. And what will be the minimum value, tell me? Yeah, minimum के लिए क्या चाहिए, you can see it now here. Now minimum के लिए, so this those smaller values and one bigger value should be the other directions. That means if I consider this is positive, 18 positive, and root 50 also positive, and minus root 98, अगर ऐसा हुआ तो इसमें स्मॉलर वैल्यू मिलेगा कि नहीं, चेक करके बोलिए. और भी कोई स्मॉलर वैल्यू होगा क्या, चेक करो इससे भी. Yes, root 18 plus root 50 plus root 98 का square. So this value came to be a 450. Check करो. And इसमें this value will come to be a 2. Check करिए, बोलिए this thing. Done. Next one. The VI characteristics seen from the terminals AB, they given as like this. Okay. If a variable resistance RL is connected across the terminals, the maximum power that can be supplied to RL is. Now you can see now here this graph which is given as voltage and current is given now. So if you observe carefully, and this point, so this is the voltage axis. So here this is a V and here this is the current I. अगर आपने ध्यान से देखा तो this point is nothing but what I can say, this is a voltage value 0 but current is non-zero. Current is 0, voltage value non-zero. This value which is called as what element of here? So this is, so here this value current is 0 mean that is an open circuit. This value is called as open circuit voltage now. Here this current is called as what element of here? Yes, this is open circuit voltage value non-zero. This is the short circuit current, means I can say this is ISC. All of you tell me this thing. And the open circuit voltage, that is nothing but what element of Thevenin's voltage only. So how much the VTH value, tell me now here, 20 volts. And the short circuit current, that is what you tell me now, ISC. ISC, how much this value, tell me now here, 4 amps. From this we can get the value of RTH. So RTH is given as what you tell me now, VTH by ISC. So how much this value, tell me now, 5 ohms. Now they are asking to find the maximum power. So yeah, tell me now maximum power के लिए P max, yeah, which is given as what, tell me, VTH is square by 4 RTH maximum power. That is what we can say now here, 20 into 20 by 4 into 20. 4 into 5, no sorry, 4 into 5. 4 into 5. So this 20 will get cancelled. So that is maximum power. हमको क्या मिलेगा? You tell me now here. 20 watts. Next one. Two sets of measurements are made on a linear passive resistive two-port network as shown in figure. The current through the 2 ohm resistance is, yes, assume that they given this network is a linear passive network. So that means this network is a reciprocal network. So we can apply reciprocity theorem. We can apply reciprocity theorem. We can apply. Okay. Now you can see now reciprocity theorem. So you can see now here what is the reciprocity theorem is a. Now when we have this network, when we have a supply voltage, right, so this is what you tell me now, 20 volts, and so this is a reciprocal network, and so here this current we are getting it as what, tell me, in this branch में current क्या मिला हमको? We are getting this current as a 2 amps. Okay. Now if I interchange the response and excitation, so you see this thing what happened. अगर मैंने सर्किट को ऐसा रिप्लेस किया, now here if I connect it as what, tell me now here, this thing इधर हमने कनेक्ट किया. If I say this is 20 volts, now you tell me now here this point, right? So then how much this current, you tell me now, either current be 20 आएगा, yes or no? Sorry, 2 amps आएगा. This current is also 2 amps आएगा. Yes or no? This step you understood first of all. If we interchange the response and excitation, the ratio remains same. But लेकिन here this voltage is how much here? 30. That means so here 30 by 20 किया तो हमको 30 volts मिलेगा ना? So if I multiply the excitation by constant K, so the response is also multiplied by the same constant. So that is 30 by 20 से multiply करना पड़ेगा. So that means 0 and this 2 will get cancelled. So then we can get this current as how much now? 3. So this current is nothing but what, tell me now here? The current which is there, the short path. So this current which I can say this as what, tell me now here? Short circuit current. How much this value, tell me now? That is 3 amps. Got it all of you? This current is 3 amps. But लेकिन so we need a resistance is there. So from this reciprocal network, I can find out the RTH value. What is the RTH value? That is 20 by 5 now, which is equal to 4. Resistance. So that is RTH, which is nothing but Norton's current, Thevenin's resistance, both are same only now. And thereafter, so after that I can replace this complete circuit as a Norton circuit से हम replace करेगा. This circuit को हमने Norton से replace करेगा. And this is the Norton's. So this value is how much now? 3. And here this resistance is what you tell me now? 4. And here is the current. So this current is what you tell me now? 2. This resistance we have a 2. And I need this current is required. How much this current you tell me now? This I. So we can apply CDR now here. So 5 amps is given as what you tell me now here. So here accordingly here, but here we don't want that current. If this is a 5, here also we have 5 amps is there. Then corresponding to this is also multiplied by 3 by 2 से multiply करेगा. But वो value हमको नहीं चाहिए. You can see. Now this I, which will be given as what element of 4 by 2 plus 4 into what element of 3. So how much this I value tell me? So this is 6, that is 2 amps. Check karo. All of you completed this thing, everyone. Reciprocity theorem. This problem, reciprocity theorem wala problem. So we are covering all the problems you can see now here, all kind of methods. So that is superposition theorem. Theorems में major theorems are superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, reciprocity theorem. इस theorems में आपको problems मिलेगा. So all kind of the things we are doing. Now terminal Thevenin's voltage and Thevenin's resistance at terminals A and B. Thevenin's voltage and Thevenin's resistance at terminals A and B. Now, so here also we can use a VT80 method. Here, tell me now VT80 method. So this is VT. And here this current is IT. Right. So this voltage is VT only na. And this voltage is also common voltage. And here this is a ground. Yeah, you can tell me now here. Let's write the nodal equation at this node. Now entry current, which is equal to -1 plus what I can say, tell me now here, VT by 5, and this is minus IT plus what, tell me now here, VT minus 10 by 5 equal to 0, tell me. And simplify it, VT by 5, VT by 5. So this is 2 VT by 5, 2 VT by 5. And then what else we have? This is minus, which is equal to IT This is what element of here? Minus 2. This is plus 2 plus 1. So that is 2 Vt by 5. It should be equal to what element of here? It plus 3. So that is what I can say now Vt, which will be equal to what we can say now 5 by 2 into It plus what element of 15 by 2. Now, so what is this RTH value? Tell me. That is 2.5. And the VTH value, how much you tell me now here? That is 7.5. Right. Completed. Hmm? Right. And these are the most expected questions from the theorems. So you can practice these questions: Thevenins, Nortons, maximum power, superposition. So only these are the variety of problems are there. Most of the cases you can get these type of problems only. Right. Okay, fine. Yeah, that's it. So here in the tomorrow class, we'll see some problems on the transient हम discuss करेगा. The top 10 questions in the transient हम discuss करेगा tomorrow. Fine. Okay then, see you. Bye-bye.